Yeah, sounds good. As Rich said, I'm Grant Gardner. I am currently a PhD student at Kansas State. I've been here the past 2 years. I actually grew up on a farm in southern Indiana. It's about 2,500 acres of corn and soybeans. Grew up going to extension meetings with my father, and at some point in my life, I decided that's what I want to do. And so needed to get this experience while I was at Kansas State, as it'll make me more marketable for the job market after. That being said, I think you have some papers to rate some presentations. If you could please turn those in, that would be awesome. It's something that needs to go on my resume so that I can leverage that when applying for jobs in the future. And thank you all for coming today. So I'm going to talk to you about irrigation and ethanol market effects on land values. This is some recent research by myself and Gabe Sampson. It will be published in the Journal of Agricultural Resource Economics sometime this year. This has been probably about a 2-year project for us, but we do have some exciting findings, and I'm excited to share them with you. Not moving. Okay, there we go. So looking at this graph here, we can see ethanol production and how it's progressed throughout the world. Okay. Sorry, I was reading the chat. I'm just going to minimize that so Rich can speak up if there's any questions during the presentation. So looking at this graph here, we do have ethanol production in billions of gallons for the world, starting in 2001, which is down there on the left side. You can see that the US was about half of Brazil ethanol production. And then in 2006, we did pass Brazil and became the leading producer of ethanol. And then currently in 2016, moving forward 10 years, we are definitely the largest producer of ethanol in the world, as we have almost doubled Brazil's production. So looking at this graph, this breaks down US ethanol production by states. We can see down there on the bottom that Iowa is obviously the largest producer, where Kansas falls in at about number 7 on this graph. And it is that pink section up towards the top. That purple section on top is pretty big. However, that is the combination of all other states that are not shown in this graph. Fleshing this out a little more, you can see that section 2, or that Midwest and High Plains region, is where a majority of US ethanol production is produced. And you can see on this that Kansas does fall in at one of the 9th largest, it is the 9th largest ethanol producing state in the nation. So moving into our motivation for this study, from 2001 to 2016, global ethanol production increased by 400%. This is a ginormous jump. And this, at the end of 2016, about half of global ethanol, or 25 billion gallons, is being produced in the United States. Looking at what pushed in this big jump in ethanol production, it was 2 really big government policies. The first being the Energy Policy Act of 2005, which did create the renewable fuel standard. And it also mandated 7.5 billion gallons of biofuel by 2012. Then there was a subsequent act that went through, the Energy Independence and Security Act of 2007. This built on the 2005 act and extended the goal to 36 billion gallons of production by 2022. And this did, in the past 20 years, we have seen more E10 and E15 fuel blends. I'm sure you remember that happening. As we move forward, we're starting to see lower percentage of fuel blends, but we do believe that ethanol will be an important industry in the United States for years to come. This has also come with billions of subsidies for ethanol building, and that has further pushed the ethanol expansion in the United States. So kind of mapping out this motivation, what happened was ethanol mandates triggered demand for feedstock. And in most cases, the main feedstock for ethanol is corn. And this brought localized effects because farmers receive a stronger basis and they're also closer to the terminal market. And this is reflected in farm profits as they have a lower cost of transport. This has led to really strong incentives to plant corn, especially if you are near an ethanol plant. And because corn is the main ethanol feedstock, this has led to increased irrigation behavior, especially in western Kansas, where they may not receive enough precipitation to grow corn naturally. And it has also been capitalized in land values. The value that these ethanol plants are bringing to the producer are capitalized in land values. So we are seeing land prices increase within close proximity of the plant. So looking at this graph here, you can see in that left side, the left graph there, you can see the ethanol capacity. And what we see there is we see that it increased slowly till 2005. And then when those mandates took place, there was a large jump between 2005 and 2008. And so what that did is that essentially tripled the ethanol capacity within 50 kilometers of a Kansas land sale. And then we've also continued to see increasing capacity since then as these acts are still running. When you look at land values, we can see that both irrigated and non-irrigated land values more than doubled between 2005 and 2008 as this ethanol capacity increased. The right-hand side of that graph shows the irrigation premium. So what this is the difference between irrigated and non-irrigated farmland price. And we can see that that premium has been increasing, although it's been sporadic throughout this entire time that ethanol has been expanding. And I do believe that big drop in 2013 was from the drought year, and we had a lot of issues with crops in 2013. So looking at our research question, we wanted to find if the locational benefits, so that increased basis, higher corn price, and decreased transportation costs are capitalized into land values. A preview of our finding is that we do find that irrigated parcels receive an 8.8% premium if they're located within 31 miles of an ethanol plant, where non-irrigated parcels receive a similar but lower 6.3% premium. So looking at some of these benefits, previous studies have found that ethanol production growth has led to higher agricultural commodity prices. And I've hit it 3 times now, but that is the increased corn price, increased basis, and decreased transportation cost. This leads to our question of, are these benefits conferred in parcels if the parcel is located close to the plant? Looking at the ethanol plant expansion effects, this has led to increased corn acreage. And due to this, we have seen putting marginal lands back into production. This includes taking land out of CRP or moving land that's better suited for less intensive crops such as alfalfa or wheat and using that land for corn production. My advisor, Gabe, could not make it today, but he did a similar study on irrigation expansion and found that ethanol plant placement has led to more irrigation use and more irrigated acreage within it when located within 31 miles of a plant. And since corn is the main feedstock, this is largely due to the fact that corn is the main feedstock and is better suited for irrigation. This leads to our question of, do irrigated parcels receive a higher premium than a non-irrigated parcel? So looking at past research in the Midwest, or pretty well anything Iowa East, they have found that ethanol plants increase land values. However, in these areas, there's no need for irrigation, and this causing a small difference in capitalization by land type, where in the high plains, they've had mixed conclusions. There's one study that did find an inverse relationship, meaning that as you move farther away from the ethanol plant, land values decrease. However, there's a study done in northern Nebraska where they found no effect. We do think that this occurred because they weren't able to differentiate between irrigated and non-irrigated land values. We also try and improve upon these past studies by using parcel level sales data from Kansas. All of the previous studies use assessed values or survey data where we have the actual values from the property valuation division. So looking at the data we used, we did receive land transaction data which include parcel level sales data for 1,251 irrigated and 14,405 non-irrigated transactions from 1995 to 2017, which is the span of our study. And I previously mentioned it, but we received this from the Property Valuation Division of the Kansas Department of Revenue. We collected location and nameplate capacity of ethanol plants from the National Renewable Energy Laboratory and the Nebraska Energy Office. We collected soils data, including acidic and alkaline soils, root zone water storage, and slope from Surgo, which is an internet data site. We similarly took climate data from a different site, such as precipitation, reference evapotranspiration, and degree days. All of these soil and climate characteristics would add to land value. So if a parcel receives a higher amount of precipitation, we would expect that parcel to have a higher land value than one that receives less. And we also calculated non-agricultural factors which might affect land value. This includes the distance to the interstate and various town sizes. And so looking at this table here, we can see in that first column, the number of ethanol plants really jumped from 7 to 15 in 2008. It is important to note that this includes 3 ethanol plants in Nebraska that are located within 50 kilometers of a Kansas land sale, and there is 1 ethanol plant in Missouri that is located within 50 kilometers of a land sale. We did not look at cellulosic ethanol. We only looked at corn ethanol. Looking at that next column, we can see similar thing happened with capacity, in which 2005, it was 260.5 million gallons. And then by 2008, it jumped to 872.5 million gallons per year. And then those irrigated and non-irrigated land sales just indicate our controls, which would be the land sales we have that are not located within 50 kilometers of an ethanol plant. And the treated sales would be the number of sales that are located within 50 kilometers of an ethanol plant. So looking at this map, we can see the gray dots are all of the non-irrigated land sales that have happened between those 2 dates, which I believe was 1995 to 2017, where the irrigated land sales are denoted in blue. Those red diamonds are the locations of each ethanol plant within 50 kilometers of a Kansas land sale, and the size of those diamonds denote the size of the ethanol plant. It's kind of an interesting figure because I would expect, especially as you move towards western Kansas, to have ethanol plants located where there is a lot of irrigation capacity. However, we can see, especially in that big diamond in the middle of the state, I'm not sure what town that is in exactly, but there's not very many irrigated land sales in that area. That doesn't necessarily mean that there's not irrigation in that area, but between those years we had nothing sell. So we do use a hedonic pricing model. And what this really does is, if you've ever been on Zillow, Zillow takes aspects of a home. This includes square footage, number of bathrooms and bedrooms, land value, how many acres come with the house. And what it does is it tries to estimate how much each part of that house is worth. And so we do the same thing for Kansas land values, which we account for all of that previous data, which includes ethanol plant proximity, land and climate characteristics, and non-agricultural land values. Fun fact, that is actually my house in Manhattan, because I didn't feel comfortable throwing a random person's house on this slide. But this is the same estimation that you would see from other software. I know there's multiple companies out there doing it, estimating land prices so that you can see what land is running for. This is one example, would be granular acre value. I'm not sure about any others, but if you have any, feel free to split them out towards the end because I'd love to look into it. It's also the same as other extension land value estimates. So if you've ever looked at land value estimates from another state, maybe Missouri extension, it's the same type of method that they would use there. So we do use two measures. The first is ethanol plant proximity. This accounts for ethanol plant locations within 50 kilometers of a parcel, regardless of plant size. And so this is the average premium of each plant. This does not include for if you have the largest ethanol plant in the state within 50 kilometers. We do not account for that. This is just the average premium that is conferred to a parcel. The next is total plant production capacity within 50 kilometers of the parcel. This measure does account for the size of the plant, and it specifically looks at what would happen if a plant expanded their capacity by 10 million gallons per year. We look at how much land values in that area would increase if this were to happen. And we do calculate that at the 10 million gallon capacity per year basis. So our measure one results, I hit them previously. They're kind of what I highlighted, is that on average, if a parcel is located within 31 miles of an ethanol plant, they receive an 8.8% premium, where dry land receives a lower 6.3% premium. Looking at measure two, as we see ethanol capacity increase, we do see diminishing marginalization of premiums. And what this means is that it's more of a curved graph. So as you get to the top, you're going to confer less of a premium to your parcel as ethanol plants continue to expand. So if you had a very large plant at 50 million gallons per acre, you would receive less premium for an expansion at that plant than someone who had an ethanol plant within 50 kilometers that was 10 million gallons, because they're going to have a much larger effect of expansion and in that 10 million gallon plant. And so what we find here is that if ethanol production capacity of the plant increases by 10 million gallons per year, we expect irrigated land prices to increase by 4.8% on average, where non-irrigated parcels receive a much lower effect when expansion happens at 1.8%. So putting these into number values, looking at irrigated land in the state of Kansas, the average irrigated land price is $2,048 per acre. If there is a plant that produces 20 million gallons within that 31 miles, we do see those land prices increase by $215 per acre, which is very significant. And when you increase to 50 million gallons, we do see an increase of $326 per acre. Looking at non-irrigated land, the average price in the state of Kansas is $1,288 per acre, where if there is a 40 million gallon ethanol plant within 31 miles, we only see those land prices increase by $58 per acre on dry land. So why does any of this matter? The big thing is that farming is asset-based. Land values largely make up a majority of producer wealth, and variations in land price could affect livelihood in the long run. As we saw at the beginning, the ethanol plant expansion was very policy driven. So when those mandates took place, we saw that huge expansion. And because of this, we do find that the capitalization or the increases in land price near ethanol plants would also be policy driven. And so what this means is that if these mandates were to fall or slacken, we could see a corresponding change in land value, and the land values located near ethanol plants would decrease. And in addition, there's also the problems in Kansas with the Ogallala Aquifer and that it is depleting. We would also see a large change in land values if future water use and availability decrease to the point where we can't irrigate. You would see that irrigation premium decrease, and the non-irrigated, I would assume, would increase a little bit. You cannot quote me on that, but that's what I think would happen. So also, land is often used as collateral for loans, and if policies change or the land prices shift, these farms would have increased financial vulnerability, leading to declining income due to the slacking of bioenergy mandates or aquifer drawdown. And so just to kind of recap my presentation, We do find that land values increase within that 31 miles of an ethanol plant. Irrigated prices increased by 8.8% on average, where non-irrigated prices increased by 6.3%. We find a 10 million gallon per year expansion in capacity. It coincides with a 4.8% increase in land prices on irrigated land and a 1.8% increase on dry land. We do know that ethanol production is sensitive to energy policy, and this affects land values and thus producer solvency, and could lead to some farm issues here in the future. Thank you for coming to my presentation, and I can open up for questions.
Thanks, Grant. Folks, go ahead. Hang on a second. I'm going to make it so you can unmute if you'd like to, and you should be able to unmute and talk to him if you want, or you can put a question in the chat if you have something. There you go. You got something.
Yeah, so we did not look by region. I definitely think you would find land values differences. We just really looked at the ethanol production capacity in that area. That's actually an interesting question that I think could be delved in deeper in the future. So thank you for asking it, because that could be another paper on top of this.
Just to follow up on that, Grant, what might you expect? You know, just a guess is all I'm after, but how would it work as you moved across Kansas and got drier, generally speaking?
Yeah, so I would expect that the land in eastern Kansas, which does receive more precipitation and is more suitable for dry land, I would definitely expect dry land prices to be higher in eastern Kansas, where western Kansas, you're not receiving that precipitation, so you're going to receive less yield on your crops without irrigation. And so I think you're going to see a large difference in East Kansas and West Kansas land values. Looking at irrigation, I think that it would almost go the other way, because you would have not as much need for it in eastern Kansas. So irrigated land, unless the land quality is better, there's so many other factors going into it. But I would expect irrigation in eastern Kansas to have less value than it would in western Kansas, because it's just needed so much more in the West.
You had a question on ethanol plants and railroad tracks.
Yeah, so we actually looked at that. We wanted to control for the placement of ethanol plants, and we used that in the data set. However, we did find that in Kansas, there's only about half of them are located near a railroad, which is kind of surprising to me. The other half, they had to drive to a railroad in order to bring ethanol, or to bring feedstock in. And so that was something that was kind of interesting that I didn't realize. I just would assume that they would strategically place near a railroad so they could bring feedstock in from places other than Kansas. So we used the 31-mile radius because that is what a lot of the previous research did. We did, instead of using I'm not sure why we did, why honestly, I didn't even think about using the distance to the closest plant, for instance. Just all the previous research did use a radius. We did choose that 31 miles because that was, or 50 kilometers is exactly what most of the prior research did. We did experiment with different radiuses, and what we found was that that 50-kilometer mark is where the benefits really dropped off. So when we went to 70 or say 90 kilometers away from the plant, we started to see a larger drop off in the premiums conferred. That is something that is out of my scope of knowledge, or our ethanol plants, big users of water resources and their ethanol production process. That is something that is out of my scope of knowledge. I'm not sure what really goes on in the plant, but as we've seen, corn is, or especially in Western Kansas, has a need for irrigation, even if it is just a risk management strategy. So definitely the feedstock is very water intensive. On the process that actually happens at the plant, I'm not sure. Uh, Growing up close to an ethanol plant, I can absolutely tell you that the process of producing ethanol does cause odor and fumes and waste products. I'm not sure the process on getting rid of the waste products or any of the legal processes that goes in with the production of the odors, but they definitely do have a negative externality on the surrounding area. Normally, you'll find them pretty rural, or I know there's some in cities, but the one that's close to me is pretty rural, so that they're mitigating that the fumes and waste products from getting to the surrounding area.
Do you think the fumes are dangerous for people?
I don't think they're necessarily. I mean, they might be marginally dangerous, but I don't think that we would have this large push for ethanol production if the fumes were very dangerous.
Sounds like something we learned from hindsight.
Yeah. I'm not sure where they're at. I think I did read an article the other day that there were plans for 2 more ethanol plants in the state of Kansas. Right now, I forgot to mention this during the presentation, but right now there are 12 in the state of Kansas, and then including those 4 that were within 50 kilometers of a Kansas land sale, that boosted our numbers up to 16. And then I'm not sure where they're going, but I did read that they're at least planning or trying to plan placement of 2 more plants.
What companies own the plants? Like Shell Oil or something like that?
I'm not sure. I know when I was doing this research at the beginning, there was a group. I know the Andersons owns a group in Kansas, so that's more of a commodity-based company. They're not necessarily all going to be a large gas producer. What they'll do is they'll produce the ethanol, and then that ethanol will get shipped to a company such as Shell or a gas producer, and then that's where it gets mixed at.
Huh, interesting.
And some, I think, are cooperative arrangements too.
Yeah, I figured that, yeah. Wow.
So how much the ethanol product? So we did not look at byproducts, so I cannot answer that question. That is another interesting question that I think could be looked at in the future. We just looked at that ethanol plant placement.
Are we gonna need it if we all go electric? We all have electric cars?
So I don't know how many of you were there, but we did have the keynote speaker on Thursday morning. What was his name, Rich?
Matt Roberts.
Matt. I knew it was Matt, didn't know his last name. He actually talked about that a lot. And what he said was that, especially in rural areas, we're not going to see that large push for electric cars. We may see a push for hybrids or cars that still use gas and electricity in order to become more green, I guess. But he's not thinking that we will go to all electric, especially in a rural area. It's just not functional. As many of you know, you're driving 4 or 5 hours at a time, sometimes just to head somewhere, and there's no place to stop and charge your car in central Kansas. And so it's just a big inconvenience. And he also mentioned that although we are seeing a push for less ethanol to be mixed in fuels, we're actually seeing more drivers because it is becoming more affordable. And basically the conclusion was that he thinks we will have ethanols here to stay and that we will be using it moving forward. These larger cities, you may see more of that electric push, but especially rural areas such as the Midwest or the High Plains, you're definitely going to still see increased fuel uptake.